Welcome you all again in my YouTube channel. Today a new chapter I will continue, that is carbon and its compound. The chapter is basically for the students of class 10. So this chapter is huge. This is the first part I am making for you. After that second part, third part you will get. So let's start our topic. So the first Today, in the first video, I am sharing with you the basic or common knowledge regarding the carbon. So, if I say कि what are the basic properties of carbon, what will be your answer? Now, ma'am, the basic property, the first we can remember कि carbon is non-metal. Yeah, definitely it is a non-metal because it has low melting and boiling point. We cannot get the metallic sound from carbon. The metals are able to make the ionic bond, ionic compounds, but carbon forms covalent bond, covalent compounds. Moreover, it is a very versatile element. Versatility, that means in our day-to-day life, every day, in each and every in each and every substance that we use, there we get the carbon. If we check the structure of plastic, there also we get the carbon. Then charcoal, carbon. If I say regarding diamond, that is carbon. Here I am using my pencil. The pencil nib is made of graphite. Graphite is a form of carbon. So versatility, that means in different structure, in different formation are available in our earth, where we can get carbon. Fine. Our food materials, our garments, there also carbon atoms are present. So each and everywhere carbon atoms are present. If we see their structures. Fine. So you can say ki ma'am, regarding that we must say carbon is available on the earth in ample in nature. Yeah, in ample percentage on the earth we get the carbon. Fine. Acha. Next is that allotropy. Allotropy is a property of carbon. So what is allotropy? Now allotropy means different formation of carbon or different segments of carbon are available in the art that we can see, like graphite, diamond, fullerene. These are different form of carbon. Here the structures are different. If we check the structure of graphite, structure of diamond, structure of fullerene, the all structures are different. Fine. But what are the basic element there? The element is carbon. In the graphite, without carbon, nothing you can find. In diamond also, except carbon, nothing you can find. Fullerene also, same thing. There is only one element present in the fullerene, that is carbon. So why we get the different substance? Due to their different structure. If we check the structure of graphite, that is hexagonal. The carbon atoms are formed just like a chain and it will form a hexagon. Now just shift to diamond. So in the diamond, what we can see? Ki one carbon atom is bounded by other four carbon atom. Okay, so this is how different structures of carbon make different formation of substances. So in that case, we say that um, graphite graphite is a very good conductor of electricity. But what about the diamond? Diamond is not a good conductor of electricity, but it is the hardest substance or hardest or purest substance that we obtain from carbon. So by using the graphite, we can cut the glass slab. But what about the graphite? What about the graphite? Graphite is soft. But both the things, both the substances we are getting from carbon, but see the differences. Where diamond is the hardest, but graphite is soft. Fine. And their properties are also different. Carbon are the main substance. Carbon is the main element present in diamond and graphite both, but still graphite is a good conductor of electricity, but diamond is not. So how we get the variation? Due to different structure of carbons, and this is called allotrope, and the property is allotropy. Fine. Acha, if we see C60, what do you mean by C60? C60 means this is fullerene. Why we do use the fullerene? Nowadays, fullerene is very useful in the case of medical science. To make the treatment of cancer, we are trying to use the fullerene. This is called Buckminster ball. This is another name of that. Why we say Buckminster ball? Because of the shape of the fullerene. It looks like a ball. Okay, how many carbons we get here? 60. C60 means fullerene. Another name, Buckminster fullerene. Fine. Acha. Next property we can say like low melting and boiling point. If we see different compounds of carbon like methane, ethyl alcohol, acetic acid, so there CH4, this is methane, then acetic acid, CH3, COOH. If I say ethane, C2H6. If we say ethanol, ethanol, C2H5OH. So these are the examples of compounds that we get from carbon, and these all are having the low melting and boiling point. Like if we consider regarding the methane, so we get the melting point like 90 Kelvin, boiling point will be 111 Kelvin. So their melting and boiling point are low, and what indicates? Now this thing is indicating regarding their covalent structure, कि the attraction power between the molecules are not so high, so attraction is less. That is why they are making covalent bond. If we think about the ionic bond, ionic compound, there definitely we find the attraction between the molecules that's so high, and that's why we get high melting and boiling point, but here we get low. Why low? Due to their less attraction power between the molecules. Okay, so up to now we have learned ki allotropes. What are the allotropes? Then versatility of carbon. After that, some examples of carbon compounds, then the covalent bond of carbon and the examples of that, why we get the versatility, why we get the allotropes, as well as it has the low melting boiling point due to less attraction power between the molecules. So here we have learned the basic thing regarding the carbon. Now, one more thing I will discuss in this video, that is catenation property and tetravalency. So, catenation and tetravalency, these two are the property of carbon. Tetra means 4. Valency means valence. Valence means in the outermost orbit of any element, the number of electrons are present. They are to be shared with another atoms, or the atoms or the atom can exchange the electron. Some atoms are able to take the electrons, some atoms are able to lose the electrons, and from where they will lose or they will take, from the outermost orbit, the electron will be sharing. It will be either lose or discharge, or instead of discharge, some electron will come inside to the another atom. So this is how we can say कि in carbon the valency of it is 4. Why it is 4? Because in the outermost orbit of carbon we see total 4 electrons are present. So in that case, if there will be the question of taking of electron or losing of electron, then how many electron it can lose or it can take? Like 4. So in the outermost orbit, the number of electrons present, that is to be called valence electron. So here in the carbon, we see in the outermost orbit, total 4 electrons are present. So the valency is 4. And that is why we say the tetravalency. So maximum 4 bond is able to make by the carbon. So carbon can make max to max total 4 bonds due to tetravalency. Fine. Now this 4 bonds carbon can make by any other atom like oxygen, hydrogen, nitrogen, sulfur. Okay. And next is that catenation property. Catenation property means self-linking property. When the atoms of carbons are self-linked to make a long chain, that is to be called catenation. Okay, so we can see a long chain of carbon. This is called catenation property. And in carbon family group, means in periodic table, when you check the carbon family, you must get another names like silicon, germanium, strontium, lead. So they are also having the property of catenation. But who has the tendency to show the highest property or highest catenation property? That is the first member, which is carbon. Carbon is the first member of the family, carbon family, right? So it has the highest tendency to show the catenation. So there is a very important question ki compare the catenation property between carbon and silicon. Definitely you will tell ki carbon has the highest tendency because the catenation property of silicon is not so stable like carbon. Where we see the catenation property of carbon is very stable and with a high power, because we have said like the self-linking property of carbon to make a long chain is called catenation. So definitely you can understand that we need a lot of energy to make the catenation. Fine. But if we see in silicon, so there what we can find, the catenation property, definitely silicon has catenation property, but the tendency is very low because the chain is unstable and less energy is required compared to carbon. Okay, so this much things are sufficient for the first part of the video. Next, in the second part, I will continue the next portion from the carbon chapter. Okay, so bye everyone.